Hello friends, welcome to my YouTube channel Computer Science Classes by Nikhil Srivastava, and in this video we will study the difference between a clustered and a secondary index. So if you have watched the previous video, then we discussed about indexes and we saw indexes are used to speed up queries, and we also saw that how you can create indexes, you can drop indexes, and we saw that the index is almost like working with the index of a textbook. For example, if you have a textbook, then if you want to search a particular lesson in that textbook, you don't have to scan the whole textbook, each and every page of the textbook. For example, if the textbook has 1,000 pages, you don't have to scan all the 1,000 pages. You have an index at the very start of the textbooks that is having so you can look at that index and go to that particular lesson of your choice. And that is the case with indexes also. They are allocated at a different memory location and they contain pointers to the actual data that is stored in the table. So this is the way indexes work. But so this was the working which we saw in the previous video, but there is one more kind of index, and that is a clustered index. So what is a clustered index? If you want to know about clustered index, you just go through the first 3 lines of this PowerPoint presentation. And I have mentioned that clustered index determines the physical order of data in a table, and it is analogous to telephone directory. It does not require additional disk space. So what does this mean? So a clustered index, my dear friends, it is not like the general index that you find in a textbook. It is more like a telephone directory. So a telephone directory, if you have searched some numbers in a telephone directory, then they are sorted on the basis of their the name, the alphabetical sorting on the basis of the name. So actually this alphabetical sorting of the name is deciding at which number will come at which place. So the same is the case with a clustered index also. A clustered index, it will determine the order in which data is occurring in a table. So just let us try to understand this with the table, and just keep these three other 2 points also in your mind. That table can have only one clustered index. Why? Because there can be only one ordering of data in the table, and primary key constraint creates a clustered index automatically. What does this mean? Let us try to understand. Suppose this is my database, and first of all, I'll be a little graphical, and I'll try to explain what is exactly the difference between clustered and secondary index. So what we have seen till now is that if there is some table, and if the table has some rows and some columns, and this is, for example, this is my relational table, then there is separate memory allocation for the column on which you are declaring an index. For example, you are declaring, suppose this is this is the salary column, and on the salary column you are declaring an index. So the salary column, it has values, say about 2000, 1000, and say, for example, 500. So the values will be what? The values will be put in ascending order in a sorted fashion. 500 and then 1000 and so on. I have explained it in the previous video, so I will not go in the depths of it. But this is the way that was happening previously with indexes. But with clustered indexes, it is something different. So clustered index is actually determining the order in which the rows will be stored in your table. For example, this is the table, and if you create a clustered index on, suppose this column, you create a clustered index. Suppose this is the ID column, and you create a clustered index on the ID column. Then in the actual table itself, the rows will be sorted according to which? It will be sorted according to the ID column. So for example, if it will have ID column will have sorted ID values. So, and the data will be actually sorted on the basis of the ID. But in case of these indexes, these indexes are also called secondary indexes. So secondary indexes, the actual data is not sorted. Only the column on which you are declaring an index, that is sorted, and it contains pointers to the actual rows on which data is stored. But here in the case of clustered indexes, these clustered indexes. So this is a clustered index. Okay. So in case of a clustered index, the data is actually sorted on the column on which you are declaring a clustered index, and these were the secondary indexes. And now you can also better understand that why Why there can only be one clustered index on a table? See, in the second point, if you go, a table can have only one clustered index. Why can table have only one clustered index? It can have only one clustered index because there can be only one ordering of rows in a table. Clear? This is for example, if this is your table, there can be only one ordering of rows in this particular table. So that is why a table can have only one clustered index. But it is possible for me to create separate allocation and have I can create a different index on the same two secondary index or more than two secondary indexes on the same table. That is completely possible, and it is totally feasible. But in case of your clustered index, there is only one clustered index that exists in the whole table. Okay, so this way it's got a little clumsy, but this is the general understanding of indexes, of clustered and secondary indexes. So secondary index we have already covered in the previous video. I'll just tell you again, but let us now go to the database and try to explore what are exactly clustered indexes. So I will what I will do, I will create a table. Suppose the name of the table is test8, and in this table I just create a serial number column, and I just create a table. So I've created this table, and I will insert some random data into this table. Suppose I say insert into test8 values. I will insert 11, and then I will insert say 5, and then I will insert 3, and suppose then 7, and okay, 15, 16, or maybe anything like that, 13 and 9. So I have stored some random data inside this table, and then when I say select star from which table, from the test8 table, then what do you get? You get the data in which you actually inserted the order in which rows are coming in this table is the order in which you inserted the data. So you first of all inserted 11, so 11 is coming first. Okay, in this way data is coming in this table. So if you just go and explore this table, so you go to you fetch out some information from the metadata view. So what was the metadata view? For information underscore schema dot inodb underscore sys tables. First of all, I need to find the table ID. So what will I say? Select this we covered in the previous video. Select table ID from this metadata view where name is equal to, so I will give the name of the database, that is the publisher database, and followed by the name of the table, that is the test8 table. So here you get, alright, it is InnoDB. Okay, so the ID of the table, that is the test8 table, is 1580, and then I will write something like this, where table underscore ID is equal to what? It is equal to 1580, and I will say select star from information schema dot inodb sys indexes, and I will select the whole metadata views. So I will say select star. So now you are getting that there is a general clustered index, and there is already a general clustered index, and that clustered index is, it is saving the data in which it is ordering the data according to the way you inserted the data in insertion order. But now let me do one thing. Let me create a primary key constraint on this table. How will I create it? I will say alt table, which table? Test8. Add a constraint, and this is a primary key constraint, primary key, and it is inserted on the serial number column of the test8 table. And I will add this constraint. Now again I will if you issue some DDL command on a table, then the table ID often changes. So I'll have to again find the table ID. It has changed to 1581. See, previously it was 1580, so now it has changed to 1581. So I will now fetch the information with this ID. 1581. So now you see that there is this index is gone, and its place has been taken by this which index, this primary key index. So this proves my third point. So this index is of type 3. It's a kind of clustered index. So it kind of validates my third point that primary key constraints creates a clustered index automatically. And now if you go and select star from table, from which table? From the test 8 table. So you will get data in sorted order. Okay, so you can see actually the data in the table is sorted according to the serial number values. Why? Because the clustered index has been created by the primary key on the serial number column. Okay, so that is why according to the serial number column, values of the serial number column, the data in the table is actually shuffled or sorted. So this is the working of a primary key constraint, and a primary key constraint automatically or implicitly inserts a clustered index on the table. And since there cannot be only one primary key constraint on a table, so there can be only one clustered index for the whole table, but there can be more than one secondary indexes. And my dear friends, one more thing that I would like to tell you is that you can create if you add a unique constraint to a table, then also it creates an index on the table. How it does it? Let us try to see it. For example, I'll just alter the table and add suppose a column, suppose name, and suppose I say the name is of varchar 20. Okay, alt table. Okay, so what was the name of the table? Test 8. So I've added a column name, and then I will add a constraint to this table, the unique constraint on the name column. Alt table test 8, add constraint. And what is the name of the constraint? Suppose I say unique underscore name underscore test 8 table. So a unique constraint on the name column of the test 8 table, and it is a unique constraint, and on which column? It is on the name column. So I have created a unique constraint. Now again, if you find a table ID that is coming out to be 1582, and if you say something like this, then you will get two constraints on this table. So there is one more constraint, one more index on the table that is that has been created by the unique constraint. So this is not a clustered index, but it's also an index on the table. And it can have many secondary indexes. So secondary indexes we already covered in the previous video. So I will go over here. Then I just told you secondary index is just like the index of a textbook, where it is allocated separately and it contains pointers to actual memory locations of the data. So that is what I've written over here. Secondary index is the same as index of a textbook, where data is stored in one place and index in another. The index will have pointers to storage locations of the data. And always, my dear friends, in MySQL, secondary index store data in ascending fashion, ascending order, and there can be more than one secondary indexes on a table. For example, I can we saw in the previous video also, in the employees table we created secondary indexes on the commission column also and on the salary column also. So this is the difference between a clustered and a secondary index. And again, to repeat, clustered index determine the actual form in which data will be stored in the table. And so this completes my discussion of indexes. And indexes, although they come with a lot of advantages, so this indexes can give you very fast searches, but there is also some disadvantages that are associated with index. That what is the disadvantage? That insertion and deletion in a row becomes a heavy operation. Why it becomes a heavy operation? Because if you have created an index on some column and you are inserting a new row in that table, then that index has to be shuffled. The entire structure of that index has to be shuffled. That is why indexes are costly as far as insertion, deletion and updation operations are concerned. Okay. Thank you so much for watching my videos. Please do keep on liking, subscribing all my videos, and do keep ahead moving in life with determination and courage. Thank you so much.